the Earth is not alone. In recent years, scientists have discovered that our planet is just one among billions that exist in our galaxy.
There's a really decent chance that there are more planets in the galaxy than there actually are stars.
Now, we are scanning these planets for evidence of atmospheres, liquid water, and even life. With the James Webb in operation, this discovery is only a matter of time, but we are ready for it.
In recent days, a rather curious planet was discovered by NASA's test satellite 100 light-years away from us.
NASA has announced the discovery of a new Earth-sized planet orbiting its star's optimistic habitable zone. Scientists say liquid water could be present at some point in the planet's history. The planet, TOI 700e, is a part of the TOI 700 system.
With 95% of the size of Earth, TOI 700e is likely a rocky world orbiting a non-red star in the habitable zone, where the temperature is suitable for liquid water. This planet is part of a system with 3 other planets, 2 of which may also be habitable. However, what makes this planet special is the idea that an increasing number of Earth-like planets have been found in space, with many of them, like TOI 700e, being worlds with much more surface water than Earth. This reveals something curious. Many of these planets carry the most important and extremely necessary component for life as we know it. Discoveries like this have changed a paradigm that humanity has had since its inception, and lasted at least until the mid-1990s.
If there is life out there, to how many and what kind of life can exist out there?
In that year, astronomers Alexander Wolszczan and Dale Frail began the first observations of planets outside the solar system, the so-called exoplanets. However, unlike TOI 700e and K2-18b, the exoplanet discovered at that time orbited a pulsar star, an extremely hostile place for any type of life to exist. Nevertheless, it was just the beginning of the discovery of more than 5,000 exoplanets, all found in just over 30 years. Scientists estimate that of these 5,000, there are about 55 candidates for Hyceans, planets covered in oceans like TOI 700e and K2-18b. Mathematical analyses go even further, estimating that there may be billions of these types of planets just in the Milky Way, waiting to be discovered. This category of planets currently holds the strongest candidates for extraterrestrial life, with scientists hoping to confirm this hypothesis with future observations using the James Webb Space Telescope. And if many planets that can host life out there don't look like Earth, but instead resemble something extremely different? What if most of them were composed of unusual worlds, with a very large ocean underneath teeming with life? A relatively recent study made exactly that assumption. There could be 17 known planets not so distant from us that could be extremely similar to something we have here in the solar system, such as the ice moons on Saturn, like Enceladus. These planets may have extremely similar effects to those of Enceladus, with extremely large oceans, containing much more water than Earth, hidden beneath the ice layer, protecting all life within. But what would life be like on these ice exoplanets and on Earth-like rocky planets, which inhabit stellar systems with twice the lifespan of the solar system? Is it possible for some form of life to exist that is more evolved than ours? Observations from the past few months indicate that there is a fairly high chance that many of these cryovolcanoes found on Enceladus are emitting signals of possible life on the surface. In other words, Enceladus is currently the most likely candidate to harbor life outside of Earth, not Mars, Venus, or any other moon. However, a planned mission to Enceladus, which will land there to investigate possible signs of life, is not scheduled until possibly the 2050s. Therefore, we won't have certainty for at least another 20 years. Despite this, all these indications and observations, along with discoveries of many exoplanets with extremely similar density, have led to an assumption. What if this is really the place where we find most of the life in the entire galaxy? Is this really how life normally begins and persists for a long time? Here on Earth, it is believed that life may have started around hydrothermal vents in the depths of the ocean. It is also believed that these vents exist around these moons, and most likely on many other planets. These regions are teeming with diverse life and represent unique ecological niches that can survive for a long time in this state. Therefore, if there is alien life out there, it is very likely to be similar to this. Based on these assumptions, scientists have sought to identify the planets most likely to be similar to Enceladus, thus representing planets with the highest chance of harboring life. The main idea is quite simple. Life, as we know it, really needs liquid water. However, we know that beyond high ocean planets, water has been found in large quantities in some places. In fact, many objects definitely seem to contain liquid oceans beneath the ice layer. To maintain these liquid oceans, these planets basically need heat from somewhere. There are two main sources to achieve this. First, internal heat from the radioactive decay of various elements that remain within the planet for billions of years can produce internal heat and also sustain some geological activity. Another source is the same as we have here around Enceladus, or actually around most moons around large planets, and we're talking about tidal effects or tidal heating. Tidal heating is a less-known effect produced by various objects as they pull and stretch due to gravitational effects. Most often, we experience tides as the rise and fall of ocean levels. In many other objects, including potentially our own moon, all this stretching and twisting also produces heat and energy inside. In some more extreme cases, this essentially disintegrates the moon over time, forming rings around certain objects, which is how we believe all gas giants acquire their rings. But in most cases, moons don't disintegrate, and instead they experience quite a bit of geological activity, like the famous Io, one of Jupiter's moons. On Io, volcanism is entirely caused by Jupiter's tidal heating of its neighboring moons. Something very similar often occurs around planets or between stars, especially when they are closer to these stars and mainly in systems that have multiple planets. For example, a quite famous system, TRAPPIST-1, where there are 7 terrestrial planets orbiting relatively close to their parent star. We expect relatively high tidal effects for practically all these planets, especially those closer to the star. Some of these effects produce something similar to a huge amount of geological activity. However, for this particular study, scientists decided to focus on planets that might be a bit cooler than Earth and also a bit less dense. The reason for this would center around 2 factors. Firstly, low density suggests there might be a lot of water. Any kind of oceanic world, or any kind of world with a lot of water on the surface, would likely be slightly less dense than Earth, but potentially very similar in size and mass. The reason they wanted these planets to be a bit cooler is obviously because they were looking for planets that would have an icy surface. In other words, they wanted to find planets that were somewhat like Enceladus but larger and more massive, and also a bit like Io in the sense that they would have a lot of volcanism or cryovolcanism, as this is something we can physically observe with modern telescopes. In this case, they found that 17 of these planets could be these unusual worlds, possibly harboring life, with all of them being somewhat like Earth, a bit cooler, and experiencing high tidal effects. Initially, at least 3 of these planets are in the TRAPPIST-1 system, and the closest planet to us is also one of them. Of all of them, Proxima b seems to have the highest tidal heating, while the planets in the TRAPPIST-1 system seem to have the lowest, but still somewhat similar to Earth, experiencing tidal effects from the Moon and the Sun. With 9 of them seeming to have more tidal heating than Io, as modern telescopes can easily detect this in moons like Enceladus, and we know exactly what to look for. A very similar technique could now be used on these exoplanets. In addition to this, If we find life here on the moons of gas giants, there is an extremely high chance it could exist there too. Unlike Enceladus, the mass of this planet is very similar to Earth, but with slightly lower density. On the list of 17 planets, 2 stand out as the best candidates so far. And surprisingly, they are not in the TRAPPIST-1 system. One of them includes the one closest to us, Proxima b, the closest exoplanet to the nearest star, about 4 light-years away. This planet is slightly cooler than Earth and has a similar mass. According to previous research, it may resemble Earth in many factors, but no one really knows its composition so far. We only know it has slightly lower density, and due to that, one assumption is that it might be covered with a lot of water, especially having a very thick layer of ice. Possibly 10 to 20% of the planet is composed of water. However, it seems to receive the highest tidal heating of all planets, making it an extremely intriguing target, as it could be similar to Enceladus, but with more volcanism. However, there is a significant problem. This is not a transiting planet, meaning it does not pass in front of its own star, which prevents us from observing the elements coming from this planet. Instead, something else needs to be used to confirm what is happening on it. Another planet known as LHS 1140b is approximately 40 light-years away from us. Like the other planets, it is also in a habitable zone but a bit cooler than Earth. However, unlike others, this one is more massive than Earth, with approximately 5.6 times the mass. Technically, this planet could be a kind of super-Earth, an oceanic world with even more water and ice. It has hundreds of times more geological activity or tidal heating than the moon Io, although we still have no idea what this planet is really like. It is extremely interesting and has a high probability of hosting life, as emissions here would be extremely similar to what we see around Europa and Enceladus. The confirmation of life on that planet is just a matter of time. The list we have prepared is an exercise based on the life we know, which is us, and some information about these planets, considering the presence of water, carbon, oxygen, and suitable temperature. Assuming that the evolution level 0 means no life, and level 10 means advanced intelligent life, Earth would fall between 0 and 9.
Proxima b, type of planet, rocky terrestrial similar to Earth, discovered in 2016. Type of star, red dwarf 4.2 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. HD 33793c, type of planet, Neptunian, discovered in 2014. Type of star, red dwarf 13 light-years away. Type of life, submerged marine with a level between 0 and 1. GJ 504b, type of planet, Neptunian, discovered in 2022. Type of star, red dwarf 32 light-years away. Type of life, submerged marine with a level between 0 and 1. TRAPPIST-1F, type of planet, rocky, discovered in 2017. Type of star, red dwarf, 39 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. TRAPPIST-1G, type of planet, rocky terrestrial, discovered in 2017. Type of star, red dwarf, 39 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. TRAPPIST-1AH, type of planet, rocky terrestrial, discovered in 2017. Type of star, red dwarf, 39 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. LHS 1140b, type of planet, super-Earth, discovered in 2017. Type of star, red dwarf, 49 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. Kepler 62f, type of planet, super-Earth, discovered in 2011. Type of star, yellow dwarf similar to the Sun, 620 light-years away. Type of life, terrestrial and marine with a level between 2 and 7. Kepler 441b, type of planet, rocky terrestrial, discovered in 2015. Type of star, smaller and cooler orange dwarf than the Sun, 620 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. Kepler 1652b, type of planet, super-Earth, discovered in 2017. Type of star, red dwarf, 8 and 22 light-years away. Type of life, terrestrial or submerged marine. Kepler 1229b, type of planet, super-Earth, discovered in 2016. Type of star, red dwarf, 870 light-years away. Type of life, terrestrial and marine with a level between 3 and 5. Kepler 1544b, type of planet, super-Earth, discovered in 2016. Type of star, smaller and cooler orange dwarf than the Sun, 1138 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. Kepler 442b, type of planet, super-Earth, discovered in 2015. Type of star, dwarf star, 110 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. Kepler 296f, type of planet, super-Earth, discovered in 2014. Type of star, red dwarf, 1200 light-years away. Type of life, terrestrial and marine with a level between 4 and 7. MOA 2007, BLG 192LB, type of planet, super-Earth, discovered in 2008. Type of star, unknown, 3000 light-years away. Type of life, submerged microbial marine life with a level between 0 and 1. Ogle 2005 BLG 390LB, type of planet, super-Earth, discovered in 2006. Type of star, unknown, 21,500 light-years away. Type of life, submerged microbial marine life with a level between 0 and 1.
Interestingly, in the coming months, at least one of these planets from the list will be observed by the James Webb Telescope, which will finally provide us with some details and possible discoveries. However, for now, this is the closest we can get to physically finding objects out there with an extremely high probability of some form of life. This assumption is based on the possibility that objects like Enceladus and Europa might also harbor life within them. And this is, of course, just the first step. Planned missions to Europa and later to Enceladus will serve as a crucial step in determining if life can exist beyond Earth and if it is as common as some scientists believe. Therefore, if we find life around one of these objects or even both, it is extremely likely that all these planets also contain life. However, the most important question is, if we find nothing in both Enceladus and Europa, should we start questioning everything we know about astrobiology? And perhaps the rare Earth hypothesis, which we have discussed here and is also in the description, is correct, and life is as unique as some scientists believe. However, with all that we already have in hand, many astronomers are no longer wondering if there is life elsewhere in the universe. The question in their minds now is when we will find it. That's it, folks. I hope you enjoyed it. Tell us what you think in the comments, including your questions. And if you're not already part of our community, leave a like, subscribe, as this is crucial for the channel to gain prominence, which consequently helps us create more content like this. Thanks a lot, and see you next week.